All right, so the idea of Riemann sum is that we are going to just do signed area, but we're going to basically break it into little rectangles. Okay, so this picture right here of this example is like a perfect idea of what is going to happen. Okay, so this one is by using the midpoint of Riemann sum. Okay, so what they're doing is they're taking this function, which is created using data points. Okay, so this scenario would happen if you didn't actually have a function. You only have data points, and so you're graphing this random thing, and so you're trying to find the area underneath the curve. Okay, so they plot these points, they connect the dots. What's that? Okay. And then they say specifically that they're going to split it into 5 rectangles. Okay, so the first little thing that you need to know is this right here. Okay, this is very easy to use. Okay, you just do the B minus the A, and then by how many rectangles it tells you to split it into. Okay, so that is W. Any guesses to what W would stand for? Width. Okay, it's exactly the width of all those little rectangles. Okay. All right, so we are going to take this example, and we're going to do an upper. Okay, so this time we're going to go from the upper. Notice on this one right above, it went from the midpoint. Okay, so when it cut it into the 5 sections, it used the midpoint between these. Okay, so the midpoint between 0 and 2, you guys all looking up here? Midpoint. Okay, so this is the midpoint Riemann sum. The midpoint between 0 and 2 is 1, right? So it goes to the y value that's at 1. Okay. The midpoint between 2 and 4 is 3. So that's the height of the rectangle that it's using. The midpoint between 4 and 6 is 5. So that's the height. Okay. 5 is at 3. Does that make sense? Midpoint in between each of those rectangles. Okay, so now when they go down below here, we're going to do an upper. I don't know why my circle got moved. But anyways, we're going to do an upper. Okay, so upper means we're going to start from the upper number of whatever the rectangle is. Okay, so if we're going to, again, split it into 5 rectangles, what is my width going to be? 2 again, right? Because you did 10 minus 0 divided by 5. Which is 2, so we know that my width of these is 2. Okay, so I'm looking at my graph now, and I'm going to 10, and I'm just going to draw, I'm going to have a rectangle here, 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 and here. Okay, so to draw these rectangles, I'm going to use my upper values. Okay, so if I'm looking at the rectangle from 0 to 2, what value is my upper value for the x? 2, right? Okay, so I'm going to go up to the corresponding y value, which is up at 4. Okay, so then from 2 to 4, the upper value is 4. So I go up till it hits 4. That height is exactly the same as the 2 height, so we're going to use that rectangle. So to draw these rectangles, I'm using the upper. Okay, the upper Riemann sum, which means between 0 and 2, the upper value is 2. Okay, so what is the corresponding y value at 2? 4. So I draw that rectangle. I look at the graph. I'm looking at the graph, or you can even use the table if that helps you. Do you see the table that's up above? Okay, the value at 2 is 4. Okay, so the value at 4 is also 4. What's the value at 6? What's the corresponding y value? 2. So I go 2 and make that rectangle. Okay, what's the corresponding value at 8? 2. So that one's the same height. What's the corresponding y value at 10? All the way up at 5, right? Okay, so all I'm going to do is I'm going to find the area of these 5 rectangles. Okay, so there's a quick way to do this. I'm going to say that my summation from 0 to 10 of my function, this is just notation, is going to be the width of all of these times each of their heights. Okay, so the height on the first rectangle is 4, plus the height on the second rectangle is also 4. Height on the third is 2, height on the fourth, and the height on the fifth rectangle is 5. Okay, so if I add all of that together, let's see, we get 8, 10, 12, 17, 17 times 2. It is approximation, absolutely. So did everybody get, whoops, 2 times, what did I say? 17? So 34, right? Did everybody get 34? Okay, so that's all we're doing in this whole section. You just have to split it into whatever they want you to do. So for number 3, they're going to do 5 again. But this time we're going to do a lower Riemann sum. Okay, so that means we're going to use the lower value of those little rectangles. Okay, so again, what's my width? 2. So my width is 2.
So that's how you know, like,
exactly.
Sure.
Yep, exactly. So 10 minus 0 divided by 5 is 2. Okay, so then I can go by 2. So I got 2, 2, 8. Okay, so this time I'm going to go from the lower value. So what's my lower value between 0 and 2? 0. Okay, so what's my height at 0? 0. So this first rectangle is like not a rectangle, it's just a flat line. It has no area. Okay, then I go to the next one. So now I'm looking between 2 and 4. What's the lower value of 2 and 4? 2. And what's the height at 2? 4. So my first rectangle that I actually draw is at 4. Okay, then I'm looking now at 4 and 6. The lower value between 4 and 6 is 4. Okay, and the height of 4 is also 4. Okay, now between 6 and 8, what's the lower value between 6 and 8? 6. So what's my height at 6? 2. Okay, and then my last one at 8 and 10, the lower value is 8, so my height is 2. Height is 2 for the last one, right? Because that 8. Okay, so my estimated summation here, whoops, of x dx is going to be my height, or excuse me, my width times each of the heights. So what's my first height?
4 or 0.
0 technically. And then second height would be 4. Third height is also 4. Fourth is 2. Fifth is 2. So we get, let's see, 8, 10, 12, 2 times 12. So an area of 24.
That's it.
Okay, so this, yeah, this is it. I told you. See, you guys were like that.
Yeah. Lower is, if it's like lower, we're using some number to the left.
To the left, yeah.
And then right-handed, is that the same as lower?
No, right-handed would be the right number. So it's the same as the upper.
Oh.
Mm-hmm.
So right is the same as what about midpoint?
So midpoint is the middle, and we'll do that
They
one.
have a right-handed one too. It's the same as
I don't know. Maybe they just were like, oh, let's. The same people were talking. They just, I don't know. I don't know.
You can just say another way to call it is the right-handed, but it's
Yeah. All right. So for number 4, what's my width gonna be? So we have 10 minus 0 over 10. So this time my width is 1. So we're going by ones. And right hand is like the upper, so the right one. So we're doing every increment on this one. So we're going to have 10 rectangles. Okay. So if I'm doing my right hand between 0 and 1, Derek, put your phone down. What is my right hand value?
2.
1. Okay, so 1. So my corresponding y value is 2. I see what you're saying. Okay, and then at the right-hand one of the next one is at 2, so that corresponding y value is 4. And then at 3, we're going up to 5. 4, we're going to 4. 5, we're going to 3. 6, we're going to 2. 7 is at 1. 8's at 2. 9 is at 3, and 10 is back up to 5. Okay, so if I do my sum, my width is 1, which I'm just going to write, even though you don't really need to write 1. And then the height of each of my rectangles. So we got 2 plus 4 plus 5 plus 4 plus 3 plus 2 plus 1 plus 2 plus 3 plus 5. Did I get all of them? So if you add all those together, $31. Very nice. Good. Perfect. Everybody good on that one? Pretty simple, right? Okay, so number 5 is a completely different function, so we can kind of see this a little differently. It's a little nice to do a different one. Okay, so first of all, what is my width? So we're going to go 6 minus 0 over 3, which is 2. So we got widths of 2. Okay, so we're looking between 0 and 2, 2 and 4, 4 and 6. Right here. Okay, and now I want to think about which kind of summation I'm doing. I'm doing a midpoint, okay? So that means the middle of that rectangle. Okay, so if I'm looking at the rectangle between 0 and 2, what is the midpoint between 0 and 2? 1. Tanner, put your phone down. Okay, so the height at 1 is right here. You see where I'm going? So that's going to be the height. Now notice that that was not a nice, like, whole number there. Okay, so when it's not a nice whole number, I'm going to use the function when I'm doing my summation piece. Okay, so I'll show that in a second. Okay, so now when we go to the next rectangle, I'm looking at between 2 and 4, so the middle of that is 3. So the height at 3 is kind of, looks like about 4.5-ish. Because it's the midpoint, we're doing a midpoint. So we're doing the middle of 2 and 4. Okay, and then the third one, the middle of 4 and 6, we're looking at 5. That one looks like exactly 6. But we're not going to use that for sure. We want to make sure it's exactly. Okay, so this is how you use the function when you don't know the exact value. Okay, so you're going to do your summation, or excuse me, your integral of that. So there's your notation. Okay, so your width times the height of each rectangle. So I'm going to use my function to make the exact value of the height. Okay, so what is my height for the first rectangle? How would I do that? So what's the x value I'm using? 1. So I would simply plug 1 into my function. Okay, so you would say 1 squared plus 10. If you wanted to simplify that and call that 11, that would be okay. Okay, what is the x value I'm using for the rectangle between 2 and 4? 3. So I would just plug 3 into my function. So it'd be 3 squared plus 10. Okay, what is the x value I'm using for my third triangle? 5, the middle, 5. So 5 squared plus 10. Okay, so you could simplify this a little bit.
You just use 6 on the last one since it kind of ended up on an even number.
Well, it looks like 6, but if you plugged 5 into the function, is it exactly 6?
I don't know. Yeah.
So if you plug 5 into the function, 5 squared is 25. 25 plus 10 is 65. What's the square of 65?
That's
35 actually.
Or 35. Yeah, my brain was thinking. Weird. Okay, sorry. 35.
pretty close.
So I was thinking, oh, that's 36 is almost there. But yeah, it's close, right? But not exactly. So we can't use it unless it's exact. So then we'd have 9 plus 10, so that's 19,
So you basically hit it
and 35.
at like 1, 3, and 5.
Yeah, 1, 3, and 5, that's the x values, yep. So this
And
one
then
you
you
would
just leave
leave
that.
like that because you want it to be an exact value.
Where'd you go to college?
Okay.
What's your first day?
Good? Okay. The last one is an example where they say we're going to use 5 rectangles, but the widths are not going to all be the same. We're not going to split them into equal widths. We're going to specifically use the x values that they give to us. Okay? So we're going to use between -10 and 4. So -10 and 4, and we're going to do a right-hand rectangle. I don't know, that's just what they told us to do. Maybe they thought that because see how it looks flat right here? So to find a really good area, they chose it specifically. Okay, and then, so right hand, which one is my right value? -4, so it looks pretty much the same height as that 10. Okay, and then between -4 and 0, we're using the right hand on that one. So that one looks just slightly lower. And then 0 and 2, we're using the right hand of that one, so that one's the 2 height. And then at 2 and 3, we're using a height of 0, because 3 is 0. Okay, and then between 3 and 5, now we're going above over here. We're going to use that height. Okay. So now we're going to add those 5 rectangles together. Okay, so to do this, we can't use the exact same equation we did before because not all of the widths are the same. So we have to do a width times a height for every rectangle. Okay, so on the first rectangle, what's the width? The one between -10 and -4, 6. So it'd be 6. And then I have to use my height at 4, -4. So I would plug 4 into the -4 into my function for the height. Everybody follow that?
So you use the right hand side.
The right hand number, yep. Okay, on the second triangle, what's the width? Yes, rectangle, what did I say?
Triangle.
Thank you, rectangle. What's the width on the second one? 4. Okay, and what number are we using for the height? 0, good. So we have 2 to the 0 minus 8. So you could probably do a little mental math on that one and say 2 to the 0 is 1, 1 minus 8. Simplify that. And then third triangle, what's the width for the third one? 2. And we're using what x value for our height? 2. So 2 squared minus 8. Third one has a width of 1 and a height of 0. That was easy. Fourth one has a width of 2. And what x value are we using for the height on the last one? 5. So I plug 5 in. Okay. So now, you could go ahead and simplify this one. Do you have to, though? You don't have to. If it's as yucky as this one, I would just stop and say, that's good enough. That's going to be equal to something, and that's good enough. Okay.
Wait, so why is it 2 every time?
Because of the function up here.
Oh.
So we good? That was it? Got it, Derek?
Yep.
Good. Okay, I want you to do the first 3 problems for homework. So just 1 through 3. Just 3.